Hi, this is Martin from MB Drive Services. Welcome to our channel about variable frequency drives and drive systems. My topic today is about the input transformer of a drive system and specifically its integration or installation with respect to other components. So there we have basically two variants. Either the transformer is external, so it's a standalone component separated from the VFD. It can be installed indoors or outdoors and then connected to the VFD, to the rectifier or input section of the VFD, either through power cables or bus bars. The other variant is the integrated transformer, or also called inbuilt transformer. So in that case, the input transformer is actually part of the VFD, part of the product, and it's integrated into the same enclosure. So the VFD enclosure has like two compartments, one dedicated for the transformer and the other one for the VFD itself. Now if we look at the landscape of the medium voltage drives, some products or topologies are only available with the external transformer, so you just get separately the VFD and the transformer is a separate component. Other topologies are available with just the integrated transformer, especially those that have a lot of secondary windings. Then the cabling would be quite complex to have the transformer externally, so it makes sense to integrate it and to minimize the connections and let it done by the manufacturer. And then there are also some products where you have actually both options available, that you can select between external or integrated transformer. And especially for the last case, it's interesting to compare both variants, to understand the advantages and also the limitations, to be able to make a proper choice. So this is the subject of our video. We will compare both variants from different aspects. Now just few examples what belongs where, what are some representatives. So the VFDs with the external transformer, this can be for example the 3-level NPC, neutral point clamp topology, or the modular multi-level converter, or from the current source the LCI load commutated inverter. They come with external transformer. Integrated transformer, the same 3-level NPC, so that one can be available both with external or integrated transformer. And then typical example that is only integrated transformer is the cascaded H-bridge. It's because there are so many secondary windings that to make the connections externally would be very complicated and troublesome. So these are some typical representatives of the VFDs with external transformer and with integrated one. So let's come to the comparison of the two variants. I have listed here few points or few aspects to compare the two solutions. The first point is installation. The integrated transformer, as it's part of the VFD enclosure, it's installed indoors in the electric room, obviously in the same room as the VFD. The external transformer can be installed indoors, standing close to the VFD, or outdoors. Outdoors is the typical variant. Regarding technology, integrated transformer is dry type, so it's VPI, maybe also cast resin, but typically VPI technology, so vacuum pressure impregnated dry type transformer in that enclosure. For the external transformer, we can have any technology or type of transformer. We can have dry type theoretically as well, dry type indoor, dry type outdoors with corresponding enclosure suitable for outdoor installation, or liquid immersed transformer, either with mineral oil or with some synthetic liquid or biodegradable liquid. Regarding power rating, the integrated transformer is limited with the power. It's because it's inside the VFD enclosure, so there are some dimensions, some space restrictions, and also because the losses of the transformer, this dry type, normally for most of the solutions I have seen, they go into the room, into the electric room. So having a large integrated transformer would mean also large heat load for the electric room, which is not interesting or not so easy then for the system integration. The external transformer, there is virtually no power rating, so we can have transformer of 100 MVA or more if we have such large VFD that requires so high power. Input voltage, similar, integrated transformer is limited with the input voltage. It comes again from the fact that the transformer is inside the enclosure, so we have certain clearances, and we cannot go too high and then with the input voltage. So typically the input voltage goes up to 11 or maybe 13.8 kilovolt, and very rarely higher. But I would say at 20 kilovolt at maximum it's over. With the external transformer, again, you can have practically any voltage. There are several references of larger drives with 132 kilovolt input transformer, so the converter transformer has primary side connected to the 132 kilovolt. There are even power electronic applications, maybe not necessarily drives, but similar type of converter, not feeding a motor, but playing a role as a static frequency converter, for example 50 to 60 Hz, or in rail applications that have even 220 or 400 kV on the primary of the input transformer. So there is virtually no limitation on the input voltage. Cooling, the input transformer is usually air forced, so it's dry type, cooled with air, and there is a cooling fan typically on the roof of the enclosure. So cooling fan for the transformer, cooling fan for the VFD. So air forced is the typical cooling method. On the external transformer, it depends on the technology, if it's dry or liquid immerse type, but we have practically any type of cooling: AN, AF, AFWF, those with a heat exchanger, or on the liquid side, ON, AN, ON, AF, OFWF, or KN, AN if it would be with less flammable liquid, and so on. So also on the cooling we have the full flexibility on the external transformer. Footprint, the integrated transformer, as it's part of the VFD, it's inside the electric room. There we might be more restricted with the space, so the footprint here is optimized. Or let's say the transformer is designed to have as little footprint typically as possible. With the external transformer, there we have the flexibility, we can do it project specific. If it's standing outdoors, then typically the space limitation is not so critical. There might be, of course, exceptions, but in most of the installations when it's standing outdoors, it's not so critical whether it's half a meter wider or not. Losses and efficiency. Let's say this transform has medium efficiency, the losses might be a little bit higher in percentage. It's because of the small footprint, because we are optimizing for footprint and not for efficiency. So small transformer, a little bit saving on the material, and with a little bit more losses. On the external transformer, there we are free basically to optimize for footprint or for efficiency or for simply cost, whatever we want. Protection, here we have quite major difference. If the transform is integrated, so it's part of the VFD, then the VFD manufacturer shall and also does provide the protection of the transformer. So there is typically overcurrent protection, there is some protection for the insulation system, like surge arresters for over voltages, and so on. So at least the minimum transformer protection is already included there, and it's also tested already in the VFD factory at the end of or after the production as part of the routine tests. If the transformer is external, then the transformer needs its own protection. It's not per default protected by the VFD. So someone needs to take care of the transformer protection. It can be the VFD manufacturer, maybe if he supplies the whole drive system, or other company, or the end user himself, but someone needs to take care and install the corresponding equipment for the protection and the implementation, the settings for the relay, and so on. If the integrated transformer, the settings for the relay already are delivered by the VFD manufacturer. Design. Here what I mean is that the integrated transformer is a somewhat standardized solution. So it's part of the VFD. VFD is standardized, also the integrated transformer is standardized, meaning that there are maybe not so many options. If the customer comes with a detailed specification on the transformer, this is normally not the idea. If it's the integrated transformer, then there is the manufacturer's standard design, maybe some with few options. So there is some flexibility, but you cannot completely redesign it because the dimensions of the transformer are given and so on. So if you would like to reduce losses, for example, it would probably result in a larger transformer. It would not fit into the cabinet and so on. If the external transformer, especially in the large power range, this can be fully customized. So there you have more flexibility on the design. So this is very brief comparison of the two solutions. You see that there are quite some differences. We can summarize that the integrated transformer is more limited with regards to power rating, input voltage, and so on. On the other hand, it comes with all the internal connections between the transformer and VFD. This is all done already in the factory, so also the installation is easier. It's this kind of 3 cables in, 3 cables out concept. So for the end user, it's very convenient, but it's typically restricted to lower power range and it has some limitations. If you would like to learn more details about this topic, you can purchase one of our webinars or premium articles where we explain in detail the differences. Thanks for watching.